Okay, so for today's lesson, what we are going to be getting into is another area of our oil heat training, and that's going to be talking about our oil tanks and how they're piped. So really with oil tanks, it's really important to make sure that they're in good condition when we are looking at the operation of a furnace, boiler. Not only do we just clean and set up the oil burner, we should also really be taking a look at the oil tank as well as a part of our overall service and maintenance of that equipment, because of the fact is that when oil is delivered, it has contaminants in it. I mean, oil is not 100% clean. I mean, it's got sediment, it's got dirt, it may have a little bit of impurities that are in it, obviously, which are beyond our control. That's our refining process that the oil has to go through. But we need to make sure that the oil tank is delivering, clean oil to the burner. So in order to make that happen, we have to always make sure that the tank is obviously installed correctly, for one. We got to make sure that your tanks are regularly inspected and fixing any sort of minor defects that are maybe seen or found on them before they lead to any other major catastrophe. We should be definitely looking at the overall condition of the tanks, and obviously we're going to want to replace them if they are old, and usually with well-maintained tanks, they'll last probably longer than the furnace and burner itself. It just all depends on where they're located and the overall maintenance that's been done with them. Okay, when we are installing tanks, though, we really need to make sure that we follow code. Different towns and cities have their own codes that needs to be followed, but they cannot be any less than the International Code Council or NFPA. So we have to always make sure that we're following the set standards and codes for that particular part of the country, state, wherever it is that you are. So it's always, again, it's really important to check with your local authorities having jurisdictions to determine which regulations that you actually need to follow to properly install a oil tank. So why do oil tanks really fail? That's always a good question. In fact, some people will, maybe even ask you that question. Well, what the heck? Why is my oil tank, need to be replaced, or why has it failed? Well, the big reason is because of corrosion. Corrosion is a big part of how an oil tank is going to fail. You have external corrosion, and that is usually caused by electrical activity that occurs between two different parts of the tank, and that's usually between the tank and its piping or between the tank and other metals that are in the area. Okay, so usually the overall area of the tank is what's going to cause that external corrosion. The tank and the piping, well, we deal with copper, oil lines, and steel tanks. So with those two dissimilar metals, over time, you can start developing like an external corrosion and possible maybe leaks. If the oil tank is in contact with another dissimilar metal, again, it can create some sort of external corrosion. Now, does that happen overnight? No. I mean, it could literally take years before, this type of corrosion can take place. So for external corrosion to occur, there needs to be obviously an anode or something that is giving up electrons, okay, such like the tank. You have a cathode, we use something to accept the electrical flow, which is going to be your piping or metals in the ground or whatever it is that's there. And then you'll have an electrolyte, which is something for the electricity to travel through, and that is usually going to be water. To reduce that external corrosion, especially for above ground tanks, we have to make sure that the tank has clearance on all sides so that debris can't accumulate and hold moisture against the tank. We have to make sure that there is sufficient clearance under the tank so that plant growth does not encounter it. We also have to make sure that any scratches or rust marks are repaired immediately, and make sure that the tank is painted on a regular basis. So internal corrosion is another way that a tank can honestly deteriorate, and that is usually caused by sludge produced by bacteria. Okay, for internal corrosion to occur, you need to have water and bacteria on the bottom of the tank. So that bacteria, which lives at that oil and water line, which is usually right around here, okay, it's going to develop bacteria. That bacteria is going to develop into sludge, and that's going to settle at the bottom of the tank. And that is what's going to eat the oil and create a substance that, when mixed with oil, creates an acid. And that's going to actually corrode the metal of the tank. So when we are dealing with oil tanks, whether they're in ground or above ground, it is really good practice to actually call what's dip the tank, where you actually take like a measuring stick and put a special water finding paste on that tank, on that stick, and actually dip the tank. And if there's any water accumulation at the bottom of the tank, that paste that we put on that stick is going to actually change color, and we can actually measure how much water is in the tank. Okay, so we want to always try to keep water in the tank to a minimum. We don't really want to have too much of it in there because, again, it's going to pollute. Okay, so the best way to prevent internal corrosion is obviously to eliminate the water at the bottom of the tank. You must also determine how the water got into the tank and take corrective steps to prevent water from building up again. So what you're seeing here is these are actually signs of corrosion on the side of an oil tank, these kind of little white little blotches. Okay, so when you're looking at an external part of a tank, you're going to want to obviously see and investigate to see if you have any sort of signs of stuff like this. Okay, you're also maybe going to look and see if you have what we call bug tracks. Okay, these little guys here, this is also signs of bacteria that is eating its way through an oil tank. Obviously, if you see something like this, this tank needs to be replaced relatively fast, because these are actual weak spots in the metal, and eventually that tank will actually rupture, and you're going to have a really big catastrophe in that basement or wherever it's going to be, or wherever that oil tank is located. So the common causes for water to get into a tank is obviously through condensation, broken tank gauges, especially if you have outdoor tanks, loose or missing fill and vent caps on your outdoor pipes. Some people like to take like old sauce cans or soup cans or something like that and kind of stick them over the pipes. Sometimes you're going to want to definitely look underneath those cans if they are there to see whether or not the fill and vent caps are actually there. You're going to want, it's pumping oil from an old tank into a new tank. So remember, oil is going to have, especially if it's been sitting in a tank for a while, it's going to have those impurities in there. So sometimes just simply pumping it from an old tank to a new tank, you're going to put water in the new tank. And failing to drain the water from a tank before installation. Okay, condensation can be greatly reduced by installing tanks indoors or in some sort of like enclosure so that it's protected from like the sun, because remember, a lot of your oil tanks are painted black. You know, black absorbs heat. So inside that tank, you're going to develop condensation. That condensation is then going to mix with the oil, and you're going to have water at the bottom of the tank. Okay, if you're going to have a tank that is located outside, you can reduce it by painting it a lighter color and protect it from direct sunlight. If you have outdoor tanks, it's good practice to paint them white, because lighter colors is going to reflect heat and is going to kind of reduce that condensation effect that's actually happening inside the tank. Gauges and caps should always be inspected regularly and replaced when necessary. So installing a tank, you got to really make sure that you know what you're doing for the first part. You have to take into consideration the following questions. What size tank do we need to best suit the application that we are dealing with? What's the best place to install it? Is it going to be in a basement? Is it outdoors? Where would we need to put it? And if it's going to be outdoors, where can I put it where it may not be in direct sunlight, 24 hours a day or whatever? What type of tank is going to be best to take care of the heating needs of the home? So when it comes to sizing, an oversized tank can cause service problems, such as poor fuel quality. Okay, the fuel oil has a shelf life, and it does deteriorate over time, and obviously corrosion. Large tanks usually build up more water from condensation. The bigger the tank, the more surface area you got. The more surface area, the greater the chance of developing corrosion. So in general, the right size tank is one that's going to hold roughly about 1/3 of the customer's annual consumption. Okay, so for an example here, we have a customer that uses roughly 900 gallons of oil a year. So a 275 or 330 gallon oil tank would be sufficient for that type of application. How do we get to that number? Well, we take 900 and we divide it by 3. Okay, 1/3. So that comes up to about 300 gallons. So roughly a 275 or a 330 gallon tank would be sufficient for that particular home or business or whatever it is that we're dealing with. The location of your tank, again, is also really, really important. Where is it going to be? Is it inside a building? Like I said, usually a basement, maybe a utility room, in a garage, wherever it's going to be. If it's going to be outdoors, is it going to be above ground or is it going to be underground? Before selecting a tank, be sure to consider regulations regarding the setbacks for those tanks. Okay, how far away does the oil tank need to be from a heating equipment or an ignition source? How far away does the oil tank need to be if it's going to be outside from a property line, from buildings, other buildings, doors, windows? So we have to make sure that we're following those local codes. Okay, any sort of meters that may be around. Say maybe there might be a gas meter in like a condo complex or something like that. Where does that oil tank need to be? Also remember to locate the tanks where the delivery vehicle can safely park during filling. Okay, we want to make sure that the oil delivery guy has at least a good line of sight for his truck to where he's filling. It will be accessible for inspection and servicing. Okay, any oil release will not easily enter a drain, well, or waterway. Okay, those are also really important things to look at when you're trying to pick a tank location. Also, will it not be exposed to corrosion or damage from dripping water, falling ice, vehicles, whatever. Inside tanks, above ground tanks, indoor tanks should be installed whenever possible. In fact, I think inside tanks is really probably the best way to go, if at all possible. These installations offer a number of advantages over outside tanks, including that the oil is usually warmer, which does help with viscosity issues, because obviously when you're dealing with oil that is warmer, it's going to flow well or flow better, and it won't gel or have cold weather performance problems. Okay, there are fewer temperature changes, which means the oil will last longer. Okay, because remember, it does have a shelf life. So if oil is at a more of a relative temperature and it doesn't have a massive fluctuation in temperature, the oil is going to last longer. You're going to have less problems with it. If a leak does develop, it can cause an odor, which quickly alerts us to a problem. Okay, if it's underground, we don't necessarily find that problem until it's too late. Okay, it's easier to inspect because obviously it's visible, and you have less condensation in the tank. Why? Again, because it's at a relatively constant temperature. Okay, it's also important to follow codes and instructions regarding tanks that are indoors. Okay, distance from the tank to a burner. They have to be at least 5 feet away from the burner. Your size and height of your vent pipes is also important. You have to follow your local code. What is the minimum size for your vent, and what's the minimum size for your fill? Your size for your fill pipes, your fusible valves at the tank, your fusible valves at the burner. You have to make sure that all these components are there when you are installing a oil tank. We have to have some sort of way to shut the oil off in the event of an emergency, and obviously when we're servicing. Okay, the fill and vent lines, they must be pitched towards the tank. All tanks should have a vent alarm on them. All tanks should have a tank gauge. All systems should have an oil filter, and it can be located at the tank, at the burner, or at both the tank and burner. The copper oil line from the tank to the burner should not touch concrete or soil, and this can be done by sliding the copper oil line into plastic conduit or plastic pipe, or by using a coated copper line. So if you're dealing with tanks or oil lines that are going to be underground, it is really good practice before they pour the concrete over it, that the oil line gets installed in a copper or in a plastic tubing, so that it does not come in contact with any other types of foreign matter, so to speak. Obviously, older homes didn't do this. I mean, if you could probably go into a basement if you have it now, you could probably see that the oil line just kind of sticks into that concrete. That's just the way things were done back in the day. But obviously, newer installations, we now put them in a plastic sleeve or some sort of protective enclosure when they're going through the ground. Or what we simply do is we just take those oil lines and we abandon them and just basically cut them at the floor, and then just run a brand new oil line along the floor using that nice protective coated copper oil line, so that it doesn't corrode when it touches the concrete. Outside oil tanks, above ground tanks that are outside, if there is no room for a tank inside the building, it must be installed outside. So it's a good idea to install the tank in a secondary containment type system, or in an enclosure that protects it from the elements. Okay, the outside oil line should be connected through the top of the tank and insulated to where it actually enters the building. So if you look at our picture here, you have our oil lines right here. In this case, they're using ball valves to shut the oil off. But this oil line right here is insulated, and is going to be insulated all the way to where it actually enters into the home. Once the line is inside, then it should be connected to a thermal shut-off valve, such as a firematic valve. And then the oil filter should not be installed outside. It can be installed right after the valve where the line enters the building or at the burner. So for underground tanks, they do kind of have an environmental issue, especially if they start to corrode and break down and crack. All that oil that is inside the tank is now going to seep into the soil, and that just creates environmental problems, environmental regulations, and insurance concerns. So obviously when we have underground tanks, they need to definitely be inspected a lot more and a lot more frequently. And if there's any signs of deterioration, they should be removed from the ground, and that tank should be replaced to either an indoor area or above ground, as we were just previously mentioning. When it comes to your vent and fill lines, we need to have a minimum of 1.25 inches for our vent lines and a minimum of 2 inches for our fills. Okay, so your types of oil tanks that are around, there's a whole bunch of them that are there. Okay, the most common one is our 275-gallon old round steel tank, and these have been pretty much the standard for decades, and is the most common type of tank that we have. These types of tanks are currently available in a number of sizes, anywhere from 100 gallons to about 330 gallons. Newer old round tanks have the oil drawn from the bottom of the tank to reduce the amount of condensation and sludge that's built up in the tank. You have your cylindrical types of tanks. These tanks are often found in mobile homes and in places where space considerations made it easier to install and service than when having an old round tank. These types of tanks can range anywhere between 160 and 320 gallons. You have your externally coated old round tanks. These are corrosion resistant tanks and has a polyethylene coating on the outside of a standard old round tank. The coating protects the tank from external corrosion and serves as release barriers should the tank corrode internally. You also have your fiberglass tanks. This corrosion-proof tank is available in both single and double wall models and can be anywhere between 240 and 300 gallons. The double wall unit is a tank within a tank. The inner tank if the inner tank leaks, the outer tank prevents the release of the oil. You could also have your polyethylene steel tanks, or better known as your Roth tanks. These are also double wall tanks, and they combine an inner tank made of polyethylene with a steel outer tank. The outer tank protects the inner tank and provides secondary containment in the event that the plastic actually cracks. Your above ground tanks, you can also have, or your underground tanks, sorry, they can be your steel or STIP3s. These tanks combine the strength of steel with a factory installed corrosion protection system. These types of tanks have a protective coating over the steel that prevents external corrosion. It has a sacrificial anode that protects the steel. It also has nylon insulation bushings that electrically isolate the tank from the pipe fill, vent pipe, oil lines, and the other attached piping. Your AC 100s and ACT 100Us, these tanks include a much thicker protective coating and offer protection just like the STIP3s, but they don't have the sacrificial anodes. Your fiberglass, better known as your fiberglass reinforced plastic tanks, they never rust because they are made of corrosion resistant material. When we are installing any one of these tanks, we need to make sure that we are following the manufacturer's installation instructions and all of our applicable codes and regulations during the installation process. Always work neat and protect the customer's property and equipment that you are installing. So which means you better have your eyes open, your ears, and paying attention to everything that is going on around you when you are putting these things in. Piping connections, it is vital that all of your connections are tight and leak-proof. All threaded connections should be joined with a pipe compound that is non-Teflon, oil-resistant, and remains flexible. So be careful when you are applying pipe dope compound, and make sure to wipe away excess compound so that it does not get into the tank and your oil lines, because that can honestly create problems, and possibly, if you put enough pipe dope on it, actually plug your oil lines. Okay, your Fentonville pipes should be made of Schedule 40 steel. The pipes should be pitched toward the tank and terminate outside the building at a point at least 2 feet from any building opening, and those building openings are your doors, windows. Okay, 5 feet from any air inlet or flue gas outlets, and all steel fittings should be malleable and not cast. The fill pipe should be clearly marked as the oil fill pipe. The vent cap should have a screen to prevent bugs from making a nest inside your vent pipe. Okay, so as you can see here in this picture, we have it clearly marked that this is our oil fill. And this guy here with a little red little cap, this is going to be our vent. Any sort of holes that are on an oil tank need to be capped, as you can see here. Okay, anything that we are not using needs to be capped and sealed. Your vent alarm for all above ground and indoor tanks should have a vent alarm installed. The vent alarm alerts the delivery person that the tank is filled to the proper level. Vent alarms are not always required for residential buried tanks because they have special filling devices such as a Ventafill, bazooka, or deep fill type device that includes a vent alarm may be used. Oil lines, for normal residential use, they are 1/2-inch OD oil lines. Those are usually what's recommended. Your copper oil line should be connected with flare fittings. You should not, under any circumstances, use compression fittings. Oil line should have as few fittings as possible, and all fittings should be accessible, which means, honestly, we should never be running oil lines through a wall or in a wall or anything like that. If we are running an oil line, it needs to be as one piece as possible with very little fittings used. Your thermal shutoffs, better known as your firematic valves, these are going to be installed on the suction line or your supply line from the tank. Your outside tank should have a shutoff valve where the suction line enters the building, and an oil filter should be installed in your suction line. So the way a firematic valve works is on the interior side, right where I'm kind of circling, you have your little threaded stem here. This internal portion right here is actually like a piece of solder or a piece of material that is going to melt in the event of a fire or the valve overheating for whatever the heck reason. And when that happens, it's going to allow the valve to jam closed. Inside the valve itself is actually a spring, and so when we tighten and open the valve, we are actually pushing or pulling the valve actually open. So when this guy happens to melt or break or whatever happens, this stem actually jams downward and will actually close the valve, shutting off the oil flow to the burner. Okay, plastic or metal plugs are used to keep water and debris out of any new tank during the shipping and storage, and they must be removed and discarded during installation, and any unused tank openings must be plugged with threaded steel plugs. Oil tank inspection, again, is like one of the really important parts of any service and maintenance of an oil burner, oil piece of equipment. They should be done on a regular basis so that potential problems can be discovered and corrected in a timely fashion. This is ultimately done in 3 levels of tank inspection per NORA standards. NORA stands for the National Oil Research Alliance, and these guys are basically what kind of comes up with all of our standards that we deal with in the oil industry. So the 3 levels of inspection really is your initial inspection, which is performed before a delivery is made to a new tank or a new customer. So just to make sure that it's actually in good condition and was actually installed correctly. Then you'll have your routine inspections, which is performed during routine maintenance and tune-ups. And then you'll have a pre-delivery inspection, which is done pretty much every time the tank is actually filled. So an initial inspection provides the opportunity to notice flaws in the tank not reported by the customer. It will also ensure that the fill and vent pipes are properly connected and correctly identified. Your routine inspection can detect problems that occur after the tank has passed the initial inspection. And then you'll have your oil delivery personnel. They should be performing a brief visual inspection before and after each delivery.